Hello, welcome. Today we're going to be looking at Jacobi method. Jacobi method of solving linear simultaneous equation. Given this linear simultaneous equation, these three linear simultaneous equations, and you're told to find the values of x1, x2, and x3, how can you solve using Jacobi method? Jacobi method is a very simple method, and you're going to solve with this solution. This will be the solution. First of all, look at this first equation. Make x1 the subject of the formula. It's going to be x1 equal to, this is 9, you take this one over, minus x2, take this one over, minus x3, all over 4. Come to the second equation, make x2 the subject of the formula. It's going to be x2 equal to minus 11. Take this one over, minus 2x1. Take this one over, minus x3, all over the coefficient of the x2, which is 5. Come to the third equation and make x3 the subject of the formula. What do? Take this one over, it's going to be x1. Take this one over, it's going to be plus x3, 3x2. Then all over the coefficient of x3, 5. So you're going to have these three equations. Once you have these three equations, then your problem is almost solved. The next thing you do is that you draw a table like this. On this side, write the variables that you're looking for, x1, x2, and x3. Whereas on this side, write the number of iterations that you want to do. You might start with 1, 2, 3, 4, 5, down. Then put initial assumption of values of 0, 0, 0. Then you start solving. For the first one, you are assuming all values to be 0. So it's going to be x1, you put this equation, you have what? 9 minus x2 is 0. 0 minus x3 is also 0, all over 4. So you have 9 over 4. So use your calculator and press down the value of 9 over 4. You're going to be having 2 point something. For x2, you use this equation, you're going to be having minus 11 minus 2 into x1 is 0, x3 is also 0, all over 5. So you're going to be having minus 11 over 5. So you're supposed to be having 2 point something as well, but minus this time. Then for x3, put this equation, x1 is already 0, you're using all these values for all of them. x1 is 0, x2 is 0, x3 is 0. This one is also going to give us 3x2, 0, all over 5. So this one is going to give us 0. So these are the new values of x1, x2, and x3 that you have. So when you're coming to the second iteration, you use these values instead of using zeros. So to do the second iteration, you also put this value, you have 9 minus x2. x2 is minus 2 point something. So 2 points minus 2 point something is x2. Okay? So you have minus x3. x3 we know is 0, all over 4. So let's say that use calculator. When you use your calculator and press 11 over x2, 11 over 5, you might be getting like 2.5, minus 2.5. So you open up this bracket and get the new value of x1. So let's call the value q. Then for x2, put this, you have minus 11 minus 2 times x1. We know already x1 is 2.5 minus value of x3. We know that x3 is 0, all over 5. So you solve this down. Let's say you got m. Then you have x3 here. You put x1 is what? From the recent value 2.1 plus 3 times x2 is what? x2 is 2.5 minus 2.5 all over 5. So you solve that. Let's say you got m. You understand? Then you taking these values now, you still solve again. So here you now have 9 minus x2, the most recent x2 that you are using. So it should be m minus the most recent x3. This is n n all over 4. So remember, m and n are the numbers that you'll be getting when you simplify. x2 minus 11 minus 2 bracket x1, the most recent x1 cube, minus the most recent x3, which is what? N all over 5. Then this one, x1, the most recent x1 from this side, cube, plus 3 times x2, m all over 5. So you get new values. So let's say you got here O, you got here P, you got here R. So when solving this, you also bring this equation again, substitute these values of x, x1, x2 that you've gotten here. So whenever the value that you get here, let's say here, is almost equal to the value that you got in the previous iteration, then you know you have what we call convergence. You know convergence. And once you have convergence, then you stop. You know that the final values that you have for this, let's say you have S, D, P. These final values of x1, x2, x3 becomes your answer. So it's very, very simple. I'm using all these values to illustrate. The first thing you do is that you make x1 the subject here. Use equation 2, make x2 the subject. Use equation 3, make x3 the subject. Once you get this, that's what you'll be using to find each values of x1, x2, and x3 in each iteration. First of all, using zeros to represent, to replace all of them, substitute. Then the values that you have after substituting with 0 will be the value that you use for x1, x2, and x3 in the next iteration. Then the values that you have after substituting for this next iteration will also be the value that you use for the other iteration. So you continue doing it like that until you have a situation whereby the x1, x2, x3 of one iteration that you just finished is the same as the x1, x2, x3 of the iteration that you did after the one you just finished. So once you have that, you know you have convergence. So bring out those values, they become the actual values of your what? X1, x2, and what? x3. So, and that gives the equation. So if it is SDP, then it's going to be SDP as your value. So that is Jacobi method. In subsequent exercises, we'll be solving actual problems with this. I want you to understand the way that I've explained it. Very, very simple. Make x1, x2, and x3 the subject by picking each of the equations. Substitute 0 and get values. Use the value that you got to substitute, get fresher value. Use the fresher value, substitute again, get other values until you have similar values in two consecutive iterations. Then you know you've come to convergence. So those values you will now use as the real values of your x1, x2, and x3. We are going to see our Gauss-Seidel method, and we are going to be seeing that it's almost similar to this. Please, if you like this lecture, click on the subscribe button. Subscribe, like, share, support us in any way you can. Thank you.